Assalamu alaikum wa rahmatullah. Hi everyone. In this video, I will be solving question number 5 from the first file of the free response questions. So let's begin. Train A runs back and forth on an east-west section of railroad track. Train A's velocity measured in meters per minute is given by a differentiable function VA of t, where t is measured in minutes. Selected values for the velocity are given in the table above. Find the average acceleration of train A over the interval 2 to 8. Well, this is average rate of change formula. So to do part A, you can use the V of, we can say this is the what? This is the average acceleration. It's equal to what? Just give me a minute. Okay. Here. V of 8 minus V of 2 over 8 minus 2. We're referring for train A. So if you take these values from the table, negative 120 minus 100 over 6. This is negative 110 over 3 meters per minute squared as its acceleration. This is part A. Part B says, do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time where t is between 5 and 8? Give a reason for your answer. First of all, VA of t is what? Is differentiable, okay? So it is continuous, right? This is what we need to write first, that the function is differentiable, which means continuous, right? Now, this is t and this is VA of t. What are the interval we are having? It's from 5 to 8. What is V of 5? It's 40. V of 8, it's negative 120. The big question is that, can we insert V of t to be negative 100? Can we insert negative 100 between 40 and negative 120? Yes. So there is a t value between 5 and 8. So what do we write? We can write by the intermediate value theorem. Okay, there is a t where t is between what? 5 and 8, such that V of t is equal to negative 100 meters per minute. So the answer for the second part, yes. Please mention the word differentiable and continuous. Okay, so what do we have in part C? Okay, so part C says at time t equals 2, train A's position. So this is part C. The position of train A at t equals 2 is equal to what? 300 east of the origin station, and the train is moving to the east. Write an expression involving an integral that gives the position of train A. We are looking for the position of train A at t equals 12. So we need x of what? X of 12 from the origin station equals 12, use a trapezoidal sum with the 3 subintervals to approximate the position at t equals 12. So what do we have here? We have, we know that the integral from 2 to 12 of VA of t, right, dt will give us S of 12, fundamental theorem of calculus, right? Instead of S, let's keep it X. XA of 12 minus XA of 2, upper minus lower, it's that. Intermediate fundamental theorem of calculus. So get this to the other side, okay, to isolate x prime of a. So I'm going to write here what? Not x prime, sorry, xa of t, which is 12, sorry, okay, equals xa of 2 is given as what? This is 300. So get it to the other side, it will be what here? 300 plus the integral from 2 to 12 v of t dt. This is the first part of the answer. Okay, this is the first part of the answer. Now, we're not done with part C. It says use the trapezoidal sum with 3 subintervals to find or to approximate xa of 12. So we need to approximate this amount here using the trapezoidal sum, and then we will replace it back here. So what is the value of this integral from 2 to 12 of v of t dt using a trapezoidal sum? Well, using a trapezoidal sum, we have to go back and use the 3 subintervals as it's mentioned. 3 subintervals indicated by the table from 2 to 12. So this is the first one, this is the second, and this is the third one. So the trapezoid, the first trapezoid would be half times the first base, which is 100, plus the second base, which is 40, times the height, which will be the difference between 5 and 2. So this is what we need to repeat 3 times for the 3 trapezoid. So I'm going to write them down here. The first one will be we just wrote it, let me just zoom out. Half times 3 times, okay, so we've got half times 100 plus 40 times 5 minus 2, plus the second one will be half times 40 plus negative 120 times the difference between 8 and 5. Let me check those values. Yeah, 4 and negative 120. And the last one will be half times negative 120 plus negative 150 times the difference between 12 and 8. So this all simplifies to what? Negative 450. Again, we are not done. We need to use this amount and put it back here. So this is xa of 12 equals 300 plus negative 450, which would be negative 150 meters. Yeah, meters. So the train A is approximately negative 150 meters west, because it's negative, west of the origin station. I apologize, the recording stopped while recording this question, the battery died. So let's continue. A second train B, travels north from the origin station. At time t, the velocity of train B is given by Vb of t equals negative 5t squared plus 60t plus 45. And at time t equals 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between the two trains is changing at t equals 2. So let's draw a sketch and see what's happening here. So this is the station. Let's call it the station. Okay. And here I have train A, and here there is a train B. Okay. So this is x and this is y. Okay. So dx over dt dx over dt is the same as VA of t, and this is y, and dy over dt is the same as VB of t. Okay, now the distance between the two trains, let's name it R or Z or whatever, it's changing because the two trains are moving. So R squared equals x squared plus y squared. Now we can differentiate both sides with respect to t. So 2r dr over dt equals 2x dx over dt plus 2y dy over dt. Cross out the 2 and the 2 and the 2. Okay, we are looking for dr over dt. Now at which moment? At the moment at t equals 2, and we know that at t equals 2, this is equal to what? This is equal to 400 from the 400 goes for y, not x. Sorry. This is 400, and from the previous part C, at t equals 2, x was 300, and we can use r equals square root of 300 squared plus 400 squared to get 500 for r. This is all at t equals 2. Okay? So let's put the values here. R equals what? 500. We are looking for dr over dt equals x equals what? 300. Now v of this is what? This is v of this is v of 2, but for train A, and this is v of 2 but for train B. So this is v of 2. If we go back to the table, or v of 2 is equal to 100. So this is 100 plus y is equal to 400, and v of b is given, vb of t is given, sorry. So vb of 2 is equal to what? Negative 5 times 2 squared plus 60 times 2 plus 25. and this simplifies to what? Let me double check. I think this is equal to 125. So we can use it here times 125. So solve this one for dr over dt. You will end up having 160. It's meters per minute. This is part D.